Welcome to Xomega Videos. In this video, I'm going to show you how to build WPF desktop applications using Xomega model-driven development and code generation platform. If you don't know yet what is Xomega, it's a Visual Studio extension for modeling and building .NET applications that contains pre-configured solution and project templates for different architectures and a model project system with an XML model editor. The model project also has a slew of generators for all application layers that generate very clean code, which uses our state-of-the-art open-source C# or JavaScript frameworks, gluing the application together. In the current video, we're going to add a WPF client on top of the ASP.NET solution that we built in our main video called Rapid Model-Driven Development with Xomega. We will reuse most of the same model, backend services, and even the presentation logic thanks to the abstraction provided by the Xomega framework. If you haven't seen the main video yet, I highly recommend watching it first, as it explains most of the relevant Xomega techniques. Here is the quick recap of what we did in that video. First, we created a Visual Studio solution using a Xomega template for ASP.NET web applications. Next, we imported the model from the structure of a sample Microsoft database Adventureworks. Then we iteratively modeled a search and details views for searching and editing of the sales orders. We also modeled the services for claims-based security and implemented any custom code on the service and presentation layers. As I said, in this video, we're going to build a WPF desktop client on top of the previous solution and implement it using different architectures. We'll add a new WPF project to the existing solution using a Xomega project template to get everything pre-configured. We will reuse the same model, services, and even some presentation logic that we implemented before. Then we'll be able to run it as a traditional client-server desktop application with a simple architecture where the desktop client connects directly to the database. Next, we will turn it into a multi-tier architecture where the same service layer is hosted on a separate server and is exposed via WCF. Finally, we'll show you how to secure the WCF services to support claims-based authorization. Don't worry about missing any details in this video. The complete walkthrough for this process is available on our website, and the final code for the application is also shared online on GitHub. So let's open the Adventureworks solution that we built in the previous video. Right in the middle we have the model project that has our Xomega model and generators. Below the model project we have two projects for the service layer, one for service and data contracts, as well as other classes that are shared between the presentation and service layers, and another one with the actual service implementations using the entity framework. Up above we have two projects for the presentation layer, one for the presentation logic that is UI agnostic, which will be reused with our WPF client, and another one with the actual ASP.NET views. Now let's add a project for the WPF client to our solution. As you can see, Xomega already contains pre-configured solution for both client-server and multi-tier WPF applications. If we were to create the WPF application from scratch, we would have picked one of these solutions and repeated most of the same steps as we did in the previous video. But since we want to reuse the projects from the previous solution, I'm just going to add the individual project for the Xomega WPF client. The small downside with this is that we'd have to update some configuration. To minimize such configuration updates, I'll follow the Xomega naming conventions for the project name and hit OK. One of such updates is that we have to include the WPF views generators into the model build. Before we can run it though, let's remember that we have set some custom selection web controls on the logical tab salesperson, since we couldn't inherit those from the enumeration type. We'll need to do the same for the WPF controls, which is a good example of how to use custom WPF controls for the generated views. Now we can run the WPF views generator. We don't have to build the entire model since our changes affect only this one generator. You can see that the generated views appear under the views folder and get registered with the dependency injection container during the application startup. The standalone project template for the WPF client that we have added is set to use WCF services by default. Since we want to use the client-server architecture for now, we'll need to register the direct service implementation from the entities project instead. So I'm going to go ahead and add a reference to the entities project and use the service implementations directly. We will also need to remove the default WCF authentication from the application startup. Now, since the WPF client will connect directly to the database using Entity Framework through these services, we need to install the Entity Framework and SQL Server Types NuGet packages for this project. We also need to add Entity Connection String in the SQL Server Type configuration to the app.config file, which we can copy from the Web Applications project. And finally, we need to add initialization of the SQL Server Types at startup. This would be all taken care of if we use the client-server project template from the start. That's all it takes to configure it as a client-server application. Let's set the WPF project as the startup project in the solution and run the application to review what it looks like. The main window has a menu with all our views, so let's open the New Sales Order screen. As you see, it has the same structure as the Sales Order Details screen in the web application. The list of statuses has our decoded values, fields are using proper controls for their types, and we can even reuse all the presentation logic for the customer selection that we've added to the web application. So if I type Joseph as a person name and hit lookup, I'll get all the matching customers in the popped-up customer view. Once I select a specific customer and hit the select button, the customer details are populated on the sales order screen. And then we can use our contextual address selection logic to select the billing and shipping addresses, which auto-populate the respective address details. By the same token, we have the cascading selection logic for the salesperson working out of the box. So if I select the sales territory, the list of salesperson will be filtered for that territory only. Thanks to the Xomega framework, we were able to reuse all this functionality from the web application without having to code a single line for our desktop application. What we also got from the framework for free is a confirmation message about unsaved changes if we try to close the details window. If we open the sales order list screen, we'll see that it has the same criteria and result columns in the grid. If I try to search it though, I will get the security error message from our service that we've added before, since the current user is not authenticated. So let's see what we have to do in order to add authentication to our desktop client. We already have the login view generated from the model, so we need to open the application class and replace the start of the main view with launching of the login view as a pop-up dialog using the Xomega framework method. I also need to fix the using statements to import the appropriate namespaces. Now let's open the customized class for our login view that was generated from the model for us. This is where we can implement the actual login functionality. First, let's override the onInitialized method so that we could set the text for the save button to be login. I'm also going to add the namespaces that we'll need. Next, I'm going to override the handler for the save button to perform the login. In here, we first delegate the save operation to the underlying details view model, which validates the input, calls our authenticate service operation, and shows any errors. If there are no authentication errors, we read the user info by the specified email address and then construct the claims identity from it, which we then use in turn to set the current principal. At the end, we start the main view and close the current login dialog. That's all we need to implement the authentication for the client-server architecture. Let's run the application to check it out. As you see, we have our login dialog pop up first. It validates the required fields, and if I enter invalid email and password, it will show us the error from the authenticate operation. So let's enter a valid login for a customer user. This works, and up pops our main window. If I open a sales order list window now, I will see that the criteria by customer store and name are now hidden for our customer user, which is the logic that we've added to the web application being reused. Hitting the search button with no criteria specified returns only the orders for the current customer, which is secured in the service we are reusing. If I click on one of the orders, we will see the order details screen in the master details form, which updates if I select a different order, just like in our web application. But if I change something and click on a different sales order, our client will now show a confirmation dialog about unsaved changes. So with little to no coding, we were able to add a fully functional client-server desktop client to the existing ASP.NET application. While this client-server architecture is quite simple to implement, it may not work well if the desktop client is used by many users. You have to supply the database credentials in the app config for every client installation, have all the users update their connection strings whenever the database is moved to another server, such as during failover or disaster recovery, and reinstall the application on each desktop for any changes in the business logic. Enter multi-tier distributed architecture. With the business layer hosted on a separate middle tier, you can update the connection strings to redeploy new services with updated business logic without having to upgrade any individual desktop clients, as long as the service interfaces are still compatible. Let's see how we can add the middle tier with our business services that is implemented using WCF framework and update the client to use that middle tier. We will start by adding a new project to our solution and using the Xomega WCF Web Services project template under the Service Layer folder. As with the WPF project, we will add it to the solution folder next to all other projects, and we'll give it a name that follows Xomega conventions in order to minimize the configuration changes required. Once the project is added to the solution, let's open webconfig file in the new project and paste the database connection strings to it from the appconfig file of the WPF project. Next, let's include in the model project build the WCF specific generators. And also turn on the WCF parameter on the service contracts generator, which will allow generating WCF annotations on the service and data contracts. These annotations will require references to the system runtime serialization and system service model assemblies on the services common project. Now let's build the model project to regenerate the service and data contracts, as well as to generate all the WCF configurations. Next, we need to change the authentication logic to call the WCF services, pass the email and password, and get back the authenticated token, which will be used for any subsequent WCF service calls. Since we no longer want to call the authenticate operation directly, I'm going to replace the old code, manually validate the authentication data object, and call a utility function that came with the project template that gets the authenticated token. I also turn off modification tracking on the data object in order to avoid the confirmation message when the dialog is closed. Finally, to start using the WCF services instead of the direct service implementations, I'm going to reconfigure the dependency injection container in the WPF app_init class. In order to run the application from the Visual Studio, we need to set both WPF and WCF projects as the startup projects for the solution. Also, we need to open properties of the WCF web project and configure the start action to not open any pages. So let's run the application now. I'm going to enter an invalid email address and password, and you can see that it goes through to the main window. This is because we have not implemented authentication on the WCF services yet, and they just used anonymous authentication for now. If I open the sales order list screen and hit search, I will get an error message from our service since the current anonymous user doesn't have the proper permissions. So let's see how we can secure our WCF services. The Xomega WCF services project that we've added contains its own security token service, or STS, that is used to issue security tokens to the clients, which will be trusted by the rest of the WCF services. The process for issuing security tokens consists of two parts. First, the STS receives either a security token that it can validate, or in the case of a single sign-on, an already validated security token from a trusted external identity provider. Second, it takes the validated security token and enhances it with the application-specific security claims in the app STS class. The Xomega project template for the WCF services is initially configured with the username and password validator, which doesn't really do any validation by default, but rather has a to-do comment to insert your own validation code. So let's insert the code to validate the username and password by just calling our existing authenticate operation on the person service. Any exceptions that it may throw will be handled properly in the catch block. Also notice how we are still able to leverage dependency injection with our services thanks to the support from the Xomega framework, since it's normally not available with vanilla WCF services. Next, let's open our app STS class, which doesn't really add any custom claims by default, but has all the plumbing code set up for us and provides a to-do comment where to insert a custom code. Again, I'm going to replace the default code with a call to read the person info from our existing service and construct the claims identity using our utility method. Now let's run the application again and try to log in with invalid credentials. As you see, it won't let us, displaying the error message from the authenticate operation. If I enter valid credentials for a customer user though, it will properly let me in and show the main window. If I open a sales order list now, I will see that the customer criteria are hidden, and if I hit search, I will see the sales orders but only for the current customer. You've just seen how quickly we were able to set up the basic security for our Xomega WCF services, but your application may require additional security configuration or even a slightly different security model. One such configuration could be the use of SSL in order to enable security on the transport level. For that, you would have to update the WCF services class to use the STS mixed endpoint and also update all the service endpoints to use the HTTPS address and the mixed binding configuration. To do that, you can remove all the generated client endpoints for the services, update the endpoint configuration in the model's global config file, and then rerun the WCF client configuration generator. Similarly, you would need to remove all the generated WCF configuration for the services and then rerun the WCF server configuration generator in order to use the updated binding configuration. In the hosting environment, you would also need to install your certificate for the SSL and configure the WPF client to trust that certificate. Another thing you would want to do to further secure the WCF services is to use your own certificate to sign the messages, as opposed to the default certificate that was provided with the project template. It can be the same certificate as the one used for the SSL, or it could be a different one, and you can use the commented out code to look up that certificate in the local certificate store. You would also need to add the thumbprint of your certificate in order to trust it. Finally, you can use a third-party identity provider, which could be the Active Directory services to enable single sign-on using Windows authentication. For that, you would also need to configure the services to trust the third-party identity provider, and then make some client changes which could be more involved. Specifically, you would have to call the third-party provider with the username and password or any other form of authentication that is supported by that provider, and then use the token received from the third-party provider to get a token from your STS service. If you use single sign-on with Windows authentication, you would also need to disable the login dialog. You have just seen how we were able to leverage the model, business services, and even the presentation logic that we built for our ASP.NET web application earlier in order to create a WPF Desktop client, both in the client-server and multi-tier architectures. In the latter case, we exposed the services using the venerable WCF technology. If you prefer a more modern REST API, then you can watch how to expose the business services via REST in our SPA video, where we also added TypeScript-based HTML5 client to it. Consuming REST services in the WPF client in C# would be more complicated though, as you would either have to hand code service proxies on the client side or build a generator to automatically generate such classes from the Xomega model. Also, make sure to check out our video where we show you how to generate comprehensive detailed design documentation for the domain and service models directly from your Xomega model. So go ahead and download Xomega and order a license on our website to start building WPF and web applications using model-driven development. We love your feedback, so don't hesitate to contact us with any questions or issues. I hope you enjoyed this video, and I'm looking forward to hearing from you soon.